Respected ma'am, sir, myself Shraddha. Today I'll be giving a presentation on Fourier transform on functions on the half-line. Introduction to Fourier transforms. The Fourier transform is a mathematical tool used to analyze the frequency components of signals. It decomposes a function into its constituent frequencies, allowing for easier manipulation and understanding. This presentation focuses specifically on the application of Fourier transforms to functions defined on the half-line. Definition of the half-line. The half-line refers to the interval from 0 to positive infinity, which is usually denoted by 0, infinity. Functions defined on the half-line have specific properties and boundary conditions that differ from those defined on the entire real line. Understanding the half-line is crucial for applying Fourier series in various physical and engineering contexts. Fourier transform on the half-line. The Fourier transform for functions on the half-line is defined differently than for functions on the full real line. It typically includes a modification to account for boundary at 0, often involving a specific kernel or basis function. This adaptation allows for analysis of signals that are non-zero only for non-negative values. Mathematical function. The Fourier transform of a function f of t defined on the half-line is given by an integral from 0 to infinity. Mathematically, it is expressed as O function of omega is equal to 0 to infinity into function of t e to the power minus 1 omega t, which is differentiated, which is represented by dt. This formulation captures the frequency context while respecting the boundary condition, that is t is equal to 0. Inverse Fourier transform. The inverse Fourier transform allows us to reconstruct the original function from its frequency components. This relationship is essential for applications where we need to convert frequency domain data back to time domain. Properties of Fourier transform. Several important properties characterize the Fourier transform on the half-line. These include linearity, time shifting, and frequency shifting, which allows manipulation of transform with ease. Understanding these properties helps in simplifying complex Fourier analysis problems. Applications in physics and engineering. This Fourier transform of half-line series has numerous applications in physics, such as analyzing waveforms and signals. Engineers utilize it in signal processing, communication, and control systems to filter and analyze data. It is essential for understanding phenomena like heat conduction and wave propagation in half-time domains. Challenges and considerations. Applying Fourier transforms on half-line presents unique challenges, such as dealing with discontinuities. The convergence of integral must be carefully considered to ensure valid results. Additionally, numerical methods may be needed for practical computations and especially for complex functions. As we have already discussed, the Fourier applications in physics and engineering is engineers utilize it in signal processing, communication, and control systems to filter and analyze data. It is basically used to analyze data in signal processing, communication, and control systems. The Fourier series on the half-line has numerous applications in physics, such as analyzing waveforms and signals. The properties of Fourier transform is understanding these properties helps in simplifying complex Fourier analysis problems. Several important properties characterize the Fourier transform on the half-line. These include linearity, time shifting, and frequency shifting, which allow manipulation of transform with ease. Fourier transform on the half-line is basically for the functions on the half-line which are in the limits of 0 to positive infinity. This adaptation allows for the analysis of signals that are non-zero for non-negative values. Challenges and considerations is challenges in Fourier series is dealing with discontinuities. The convergence of integral must be carefully considered to ensure valid results. Numerical methods for computation. Various numerical methods such as fast Fourier transform, which is also known as FFT, can be adapted for half-line functions. These methods helps in efficiently computing Fourier transform, especially for large data sets. Understanding the implementation of these techniques is critical for practical applications in research and industry. Conclusion and future directions. The Fourier transform on functions defined on the half-line is powerful analytical tool with wide-ranging applications. Future research may focus on refining numerical methods and exploring new applications in emerging fields like data science. As technology advances, the relevance of Fourier analysis will come to grow in various scientific domains. As we have already seen the applications, it is essential for understanding phenomena like heat conduction and wave propagation in half infinite domains. Here infinite is positive infinite. The Fourier series is only valid for 0 to positive infinite. It is not valid for negative infinite domains. The Fourier transforms on the half-line has numerous applications in physics, such as analyzing waveforms and signals, which is the conclusion, which additionally numerical methods may be needed for practical computations, especially for complex problems in solving the real life problems. The convergence of this integral must be carefully considered to ensure valid results. Applying Fourier transforms on the half-line presents unique challenges such as dealing with discontinuities. Dealing with discontinuities is a major challenge in Fourier series. Several important properties characterize the Fourier transform on the half-line. Understanding these properties helps in simplifying complex Fourier analysis. So this is my idea on Fourier transform series. Applying Fourier transforms on the half-line presents unique challenges such as dealing with discontinuities. The convergence of the integral must be carefully considered to ensure valid results. If you want a proper or an accurate result, the integral must be carefully calculated in the Fourier series. Additionally, numerical methods may be needed for practical computations, especially for complex methods. Numerical methods for computation. Here fast Fourier transform FFT is adapted for half-line functions. Conclusion and future directions. The Fourier transform of functions defined as a half-line is a powerful analytical tool with wide-ranging applications. Future research may focus on refining numerical methods and exploring new applications in emerging fields like data science. This Fourier series can be used in data science as it is used for analyzing the data, as engineers utilized in signal processing, communications and control systems to filter and analyze data. In future research may focus on refining numerical methods and exploring new applications in emerging fields like data science. As technology advances, the relevance of Fourier analysis will come to grow in various scientific domains. This Fourier series is a really powerful analytical tool, and it can be used in various researches in future in emerging fields like data science also. So this is my idea on Fourier transformation series. Thank you.